He fired particles at a sheet of gold foil thinner than breath. They bounced back. That is not possible. Rutherford has spent 20 years trusting these equations. The physics every man in that building was trained on says the particle should pass straight through. The atom is soft, diffuse, a cloud of charge with electrons suspended inside it. Everyone knows this. J.J. Thomson proved it. Rutherford himself taught it to his own students last term. The numbers say Thomson is wrong. He sets the data down. He picks it up again. Outside the windows of the University of Manchester, it is raining. The year is 1909. The gas lamps are burning. Nobody walking past this building tonight has any idea what is happening inside it. Rutherford does not call a press conference. He does not send a telegram. He sits with the numbers until the room goes cold. Because he understands, before anyone else on Earth does, that this is not a correction to physics. This is the end of physics as anyone has ever understood it. And the beginning of something he cannot yet name. The world Rutherford works inside believes it is almost finished understanding itself. By 1909, the British Empire covers a quarter of the Earth's surface. Its universities produce engineers, administrators, and scientists with the calm confidence of an institution that has never been seriously wrong. Physics feels solved. The great questions, what matter is, how light moves, how heat distributes, are considered largely answered. What remains is refinement, decimal places, verification. The atom has been theorized for 25 centuries, since Democritus first proposed it, indivisible, fundamental, the irreducible unit of reality. The only serious argument was whether it existed at all. By 1909, most physicists accept it exists. J.J. Thomson's plum pudding model, published in 1904, gives it a shape. The model is elegant, it is widely taught. It is wrong in every particular that matters. Rutherford knows Thomson. He trained under him at the Cavendish Laboratory in Cambridge. Thomson is not a fool. He is one of the finest scientific minds of his generation, the man who discovered the electron. Rutherford respects him the way a person respects the foundation of the building they are standing in. He is about to remove the foundation. He is not yet sure the building will survive it. What makes 1909 specific is not the experiment itself. The gold foil experiment is technically straightforward. Hans Geiger is running it, Ernest Marsden is assisting. The equipment is ordinary. The result is not. The result is the atom opening. And Rutherford is the only person in the world who understands what that means. Rutherford grew up in a farmhouse in New Zealand, with 11 siblings and not enough of anything. His father made flax and railway sleepers. His mother was a schoolteacher. The only exit from a colonial farming life was through a scholarship. Ernest won one at 15, another at 18, a third that put him on a ship to England in 1895, with everything he owned packed into a trunk and a talent for physics so obvious that J.J. Thomson admitted him to the Cavendish within weeks of his arrival. What his colleagues remember is not the intelligence. The intelligence was simply there, like weather. What they remember is the noise. Rutherford could not enter a room quietly. He boomed. He laughed too loud. He swore fluently. He sang. Badly. Often. And without awareness of how badly. His student James Chadwick later said that when Rutherford was happy, you could hear it through 2 closed doors. He was happy most of the time. Not because his life was easy, because the questions he was working on were impossible, and the impossibility delighted him. The one thing Rutherford never managed to be was careful. Not socially, experimentally. He pushed equipment past its specifications. He ran trials others considered reckless. He asked questions his colleagues considered impolite. When the numbers produced results that shouldn't exist, his first response was not doubt. It was excitement. That specific quality, the refusal to be frightened by a result that contradicts everything, is what the gold foil experiment needed. It is also what makes what follows unavoidable. The experiment begins as a verification exercise. Geiger and Marsden are not trying to disprove Thomson. Nobody is. The plum pudding model predicts that particles fired at a thin material will pass through with minor deflection. The experiment is designed to confirm this, to add one more decimal place to a model everyone already believes. For weeks, this is exactly what they observe. Everything matches the prediction. The experiment is working. And then Marsden, on Geiger's suggestion, half as an afterthought, repositions the detector to catch anything bouncing backward. Not because anyone expects anything, because it costs nothing to check. 1 in every 8,000 particles comes back. Geiger brings the result to Rutherford. This is the moment. Not the experiment. This room, this data, this conversation. Rutherford looks at the number. He does not speak immediately. Then he says something that no other physicist in that building would have said. He says it is the most incredible event that has ever happened to him in his life. Then he explains why. Firing particles at gold foil and having them bounce back, he says, is as if you fired artillery shells at tissue paper and the shells came back and hit you. The room is silent. The deflection is consistent with only one thing: a tiny, dense, positively charged mass at the center of the atom. Almost incomprehensibly small, surrounded by mostly nothing. The atom is not a cloud. The atom is almost entirely empty space, with a nucleus at its heart too small to describe, too dense to imagine, carrying more energy than any physicist in 1909 has a framework to calculate. Rutherford sits with this for 18 months before publishing, because he knows that this answer does not only change physics, it changes everything physics touches. The paper arrives in April 1911. 11 pages, written in Rutherford's direct, almost impatient style. No ornamentation, no hedging, no courtesy to the model it replaces. A dense positive nucleus. Electrons orbiting at distances vast relative to the nucleus itself. An atom that is almost entirely empty space. Thomson reads it. His name is not mentioned as a target. It does not need to be. Every physicist who reads it understands what Rutherford has done. He has not refined Thomson's model. He has replaced it. Thomson says almost nothing in public. In private, he tells colleagues he does not believe it. He's 65 years old and has spent 40 years building the physics that this paper erases in 11 pages. Rutherford does not apologize. He cannot, because the data does not permit it. At a lecture the following month, a student asks what is inside the nucleus. Rutherford pauses. He looks at the ceiling. Then he says, "I don't know. And I think it will be a very long time before anyone does." He was wrong about the timeline. Within 21 years, James Chadwick, His own student, in his own laboratory, discovers the neutron. The nucleus is no longer a mystery. It is an inventory. And once it is an inventory, it becomes, for certain minds, a target. He split open the atom, and something that had been true since the beginning of time stopped being true. He did not know this yet, but he could feel it. The world receives the nuclear atom slowly, and then all at once. In the years following 1911, most physicists treat Rutherford's model as a puzzle rather than a revolution. The implications are unclear. The applications, invisible. The new atomic physics feels like advanced mathematics. Beautiful, perhaps, practically irrelevant. Rutherford himself contributes to this impression. In 1933, he stands before the British Association for the Advancement of Science and declares that anyone who expects to extract energy from the transformation of atoms is talking moonshine. He says this 1 year before Fermi begins bombarding uranium with the neutron, his own student just discovered. The discoverer who understands his discovery's full consequences does not exist. Not in any era. Not in any field. Rutherford spends his final years watching a physics he helped build accelerate past him. His students are everywhere. Chadwick in Cambridge, Oliphant at Birmingham, others across Europe and America, doing things with the nucleus he would not have fought to do. He is proud. He's also, in his quieter moments, watching something he can no longer fully follow. He dies in October 1937, a routine operation. 66 years old, his ashes are buried in Westminster Abbey, beneath the nave, near Newton and Kelvin. He dies without knowing what is coming. The men who built the bomb knew his name. Some of them had read his 1911 paper as students. In August 1945, 8 years after his death, 2 cities in Japan cease to exist inside a morning. The physics that makes this possible begins with 11 pages in April 1911. If this is the kind of history that stays with you, subscribe. Every week, one story. The people who changed everything and never got to see what they started. You don't want to miss what's coming next. There is a photograph of Rutherford taken in 1932, the year Chadwick discovers the neutron, the year the nucleus becomes something that can be taken apart. Rutherford is smiling. He looks exactly like a man who has just received very good news about something he loves, which is what he was. Thomson outlived him. He never changed his position. He did not live to see the bomb. He did not live to see the reactor, the fallout, the cities, the generations born near test sites who grew up counting the sick. He did not live to read the letters from Hiroshima survivors who described the light before the sound, the specific color of a physics experiment at human scale. He did not have to choose. James Chadwick, who did the work, who was present for the Manhattan Project, who understood exactly what his neutron made possible, spent the rest of his life wishing he had never found it. He said this in writing more than once. Rutherford is spared that. The question history cannot answer, and that this video refuses to answer for you, is whether the sparing was luck or justice. He found the door. He did not build the weapon. He did not drop it. He did not choose the targets or sign the orders or fly the plane. He found the door. And every person who walked through it made their own choice. But the door would not exist without him. So the question you carry out of this video is the same one Chadwick carried for the rest of his life. When you open something that cannot be closed, does the opening belong to you?